with a life value of 10. Each move uses 1 life.
Start.
When it gets to 0, make a sound and die. After 15 seconds,
It blows up.
regain all life.
What? It should blow up. That would be an epic victory for Mario.
All right, so how would we do this? This is a very complicated challenge.
Variable.
Variable. How did he know? We just talked about it.
Oh!
Good guess. All right, so you have to have a way. Remember what the variable is good for is for. Sorry. A variable is good for storing information that you want the program to use. Okay? So one way to do this, like Sam says, is to have a variable called lives. And we start with a value of 10. Right? And then in the loop that you all made last week for Gatorbot moves, every time it moves, you could decrease that variable by 1. And then you have to have a decision that says, when it gets to 0, check that variable every time. And if it's at 0, then you go dun dun dun, or whatever sound you want to make. Right? Okay? So y'all want to try that?
I don't think that was an option, Michael.
Yeah, it's an assignment.
I'm just trying.
Let me give you all a good example, a short example about counting to 10, or counting from 10. So where do we define the variables? Everybody remember?
What?
Where do you go to define the variables? Start box. So you click on the start box, and you see the variable entry on the bottom left. So let's name one called live.
Wait. Lies.
Right.
And then, do we keep it in the integer box?
Integer.
Do we keep it?
Yeah. And set initial value to 10. And save it. Huh? Set initial value. It has initial value in the box here. So make it integer. And integer. Value 10. Alright? So then what we want to do is every time we... Yes, Michael?
I need help. I'm not there yet.
Okay.
What's the type and initial value and stuff?
So lives, integer, initial value is right here, that one. Initial value.
You know what?
That's what it starts with. Initial means starting point. 10.
Oh.
See. Right. Okay. So now you want to say, let's do something to that. Let's check first. Let's do a simple test like we were doing before with the proximity sensor. Left sensor true, make a sound, and we'll say if that sound happens, then let's do something with that variable. So we do math. This is a new box we're going to learn about. Math. Right?
So wait,
everybody found that math box?
No, wait. I need to do what you're doing. Okay, so left sensor.
Right.
Okay, then what?
So then we say math. Everybody found the math box?
Yeah, but
Okay. Let's focus on the math box, and then you all could put it together afterwards, all right?
okay.
So in the math box, you have a variable, which we said was lives, and you see 1 to 3 means it's an integer. That it means it. And then we want to say, what do we want the operator to be?
Percentage.
Minus, because you want to reduce it to 0 every, all right?
Oh.
So we want the operator to be minus and a value of 1.
Wait, what? Oh. It says variable 1.
Constant.
Oh. Constant.
Right? So that means every time you hit that box, you wanted to look at the value of lives and subtract 1 from it. Okay, that's what it's telling you to do. So let's put that right under one of the branches. So take that math box. I'll put it under the left sensor true branch.
Left center true. Wait, what? Okay, I did it. Then what we did? Put it on.
Then we have to say, make a decision. You know, the variable is helping the program make decisions, right? So what was the decision we said to do when it gets to 0?
Oh,
It
wait
dies.
15 seconds and then it'll be.
It dies for 15 seconds, but you want to make a noise so that you know it dies, right?
And then.
So make a decision. What is the decision block? Branch. You all remember branch is the decision block? So what variable do you look at your branch block? What? You're looking at lives, right? You're trying to make a decision on the lives.
Variable.
So you want to say if it's equal to 0,
Equal. What do you mean?
if it's equal 0,
Make a noise.
Are we gonna ask?
Fart.
then make a noise. Let's go to the sound box.
Wait. Sound. Where's the sound box?
Put it under true and false.
No.
Just true.
Only if it's true, right? Only if it's 0 you wanted to make
Oh,
a
yeah.
noise.
Well, then
Make some noise.
So let's make 2 or 3 noises in a row. So one sound box, second sound box. So who could tell me the notes to make? Da, da, da.
we could do T.
Let's do tones.
T do. Let's do T do.
No.
Notes.
No.
I'll do C in octave 3.
Me, do, ti. Me, do, ti.
Okay, I'm deciding for my own.
You know-
C octave 3, and then the second sound I'll make as
Wait. We
a
have to
note
have
again.
3 sound boxes.
C, if you want to make 3 in a row.
Well, you have 3 in a row.
Right.
Okay, so
Wait,
the
so-
second one was
Let's wait. So what are yours gonna be again? What do you say?
I'm going to make it C octave 3, C octave 2, and C octave
C,
1.
2, 1.
Octave 3.
Where is that? Wait, C.
Note.
What does C3 mean?
C octave 3.
Oh, C octave 3, 2. C and 3.
Michael, you're really
Yes,
showing.
we put that right under the math,
Where's the map?
right?
Oh my.
Oh
This
my.
is interesting.
Oh, it's like it's a.
Like a bazillion.
It's like a.
Oh, I'm gonna put it in the loop.
So there's what you're saying. You're saying
it's like
that,
it's a
so there's
tornado.
2 things you're checking now, right? You're checking the sensor and trying to do the Gatorbot moves, right? So if it's a left-centered true, you're going to turn. We didn't put the turn in yet, but we're going to say in this case just do a sound. And then deduct 1 life and keep deducting lives. If it's 0, make the sound, and then last thing we want to do is pause for 15 seconds because we're saying it's going to die for 15 seconds.
So then.
So
That's
go
correct.
up to the delay box in the output.
Wait.
Milliseconds, how much milliseconds in 1 second?
Million.
No,
10.
1,000.
100.
1,000.
I'm guessing.
So 15 seconds would be how many?
15,000.
15,000.
15,000.
So it'll go ba ba ba, and then it'll die for 15 seconds, and you have to sit and wait for 15 seconds, and then it'll come back up, and it'll start checking the sensor again.
Oh yeah,
Right.
we want to put it in that loop. Then
So how do you know? A nice thing about programming like this is you could add a sound to say, okay, it's regaining its life. So let's add a sound after the delay of 50 seconds.
How about this? We can make it go higher.
Yep, right? So you could do sounds to go higher again after the delay to say, I'm getting back my life, get ready.
Where's the delay?
Isn't it could be like F? Then
You
like
do whatever notes you want.
Wait.
Yep.
Delay. Sound C1. Sound C2.
Okay. Oh, did you sound C three times or sound 1 sound?
Whatever note you want. It's up to you. This is your program.
No, sound E.
So let's put that on the loop forever. Let's test mine. I'm excited to see fireworks.
Okay, anybody have a table?
Oh.
These are real. Good working!
Yeah.
I say mine works. The loop forever just is so big.
That would be
know.
so
It's-
terrible
it had
if
to
this didn't
stretch.
work.
I know.
No.
Wait.
That was under the false thing. Should it do nothing if we do like
I did this one over here, so would that affect anything?
Wait,
No.
wait, wait,
Sure.
wait,
I
wait,
guess it
wait,
does.
wait. Anybody have a cable? Dan. Where's the cable? I need a cable. You have a cable. I have cable. Wait.
It's not working over here for some reason.
Yeah, I'm gonna try mine.
Oh yeah, it is.
Where'd that at?
2,
It died.
3,
15.
4.
See, it's not responding because it's dead.
9, 10, 11, 12, 13, 14, 15. Oh, so this is all sound.
See, it came back, dun dun dun, and then it started looping again.
So it's all sound.
Yeah.
Oh.
Oh yeah.
Try yours.
We made our first like